Algebra 2, Chapter 16.3, Solving Logarithmic Equations. Essential question, what are some ways you can solve logarithmic equations? Well, the two ways we're going to look at in this introductory lesson to this is graphically and algebraically. So let's go to this first section, solving logarithmic equations graphically. And one way to solve logarithmic equations is graphically. So we graph each side of the equation separately. So we have this equation 12.2 plus 5.4 ln x equals 12.5 plus 5.2 ln x. And ln equals the natural logarithm. And what that's going to be, it's going to be log base e. So let's go ahead and put down what each side is going to be. We have y1 equals 12.2 plus 5.45 ln x. We have y2 equals 12.5 plus 5.2 natural logarithm of x. And then b here, what will the graphs of y1 and y2 look like? Well, generally a graph of a logarithm is going to look like this. At the beginning of the year, with the parent functions of Algebra 2, you may remember something like this. So this is going to be the general shape. Starts to the right of the y-axis, increases steeply and gradually less steeply, crosses the x-axis and continues up, but at a decreasing rate. And it is the inverse of the exponential function of the same base. So we're going to see two graphs like this in this general shape. They're going to cross at some point, and that point where these graphs cross is going to be our solution, or the x value. And so it says graph y1 and y2 using a graphing calculator. Well, before starting this video, I went and entered these two equations, and here they are entered. If you press graph, we see them kind of together. We're going to change the window to better view what's going on. So x minimum -1, x maximum 5, y minimum -5, and y maximum is going to be 20, and a y scale of 5. We graph, and we really see the graphs of the two functions together, but it's hard to distinguish an intersection point, and even at that they intersect. If you go to table view, you'll notice as we increase from 1, y1 is smaller than y2, and y1 continues to be smaller than y2 up till 4. Now, when we get to 4, we see that y1 is larger than y2. So our intersection point is going to be somewhere between x equals 3 and x equals 4. Now going back to the graph, we can find the intersection point by pressing second, trace, 5 for intersect, enter, enter, enter. So we get x is approximately 3.32. So that's our solution, not the y value. So we'll say graphically, we'll say x approximately equal to 3.32. Okay, and then we'll just go on here. Solving logarithmic equations algebraically, and they give an example here of going through that. I'm going to go to the next one here, B, and sort of, you can just follow along with me on this. You have this equation, log x plus log of quantity x plus 9 equals 1. And here what we have is we're going to use the product property of logarithms, that if we have two separate logarithms of the same base, it's going to be the log of a single logarithm by multiplying this x by this x plus 9. And so what we have here is distributing. We have log of x squared plus 9x is equal to 1. So what we can do next is we can take each side to the power of 10. And when we do that, the 10 to the power of the log will cancel each other on the left side, and that leaves us with x squared plus 9x. On the right side, we have 10 to the power of 1, which is 10. So what we have here is 10 equals x squared plus 9x. Okay, and then I'm just going to write this down here. And so what we have here is if we subtract 10 from both sides of this equation, we have 0 on the left side equals x squared plus 9x minus 10. And so finding the factors of x squared minus 9x minus 10, what two numbers when multiplied together equal negative 10, but when added together equal 9? Well, those numbers are going to be 10 and 1. And so our solutions here are going to be x equals negative 10 or x equals 1, because if we subtract from here, well, anyway, those will be our solutions. Now, next thing we're going to do is check our solutions. So if we plug back in to check, what we're going to get is log of negative 10 plus log of negative 1. Guess that's just plugging back in the equation, equals 1. Well, what's going to happen here is we cannot have the log of a negative number. And for that, we can go back to the graph that I drew at the beginning here. Is the function is not defined except to the right of the y-axis. So we can't have a negative input value. And so what we say is not defined. I'll say does not exist, DNE for does not exist. So x equals negative 10 is what we call an extraneous solution. An extraneous solution is a solution that is created in the process of solving an equation. And you'll see this for logarithmic equations, sometimes for rational equation. On the right side, when we plug in the other number, we plug in 1. Log 1 plus log 1 plus 9 equals 1. So we have log 1 plus log 10 equals 1. And so we have here is log base 10 of 1 is 0, and log base 10 of 10 is 1. So we have 1 equals 1. So the solution is x equals 1. Now, we're going to go to these your turns right here, and we're going to solve these equations. And so I invite the viewer, if you can stop pause the video and then work ahead and see if you got it right. So we're going to go ahead and solve this equation. Log base 4 of 2x plus 12 plus 5 equals 8. So let's subtract 5 from both sides of the equation. So we get log base 4 of 2x plus 12 equals 8 minus 5, or 3. So what we can do next for this one is take 4 to the power of both sides, and when we do that, the 4 and log base 4 cancel each other out. So what we have is 2x plus 12 is equal to 4 to the third power. Well, 4 to the third power is going to be 4 times 4 times 4. 4 times 4 is 16, times 4 is 64. And so if we subtract 12 from both sides of the equation, we get 2x equals 64 minus 12, or 52. And dividing by 2, we get x is equal to 26. And then to check, if we put this back in, let's say log, I'll just put check right here. Log base 4 of 2 times 26 plus 12 plus 5 is equal to 8. Well, 2 times 26, let's work this out. On the left side, log base 4. 2 times 26 is 52, plus 12 is 64, so log base 4 of 64 plus 5 is equal to 8. And then a logarithm is what power do you need to raise a base 2 to equal that number? Well, 4 to the third power is 64, so on the left side we have 3 plus 5 equals 8, and we're left with 8 equals 8. Check. So x is equal to 26. Okay, here's another your turn, and I invite the viewer to pause the video and then play ahead to see if you got it right. Okay, so we have a logarithm right here, and what we're going to do is bring all the log base 6 stuff over to the left side. So if we add log base 6 of x to both sides, what we're left with is log base 6 of x minus 5 plus log base 6 of x is equal to 2. And we can use our properties here, our product properties, and on the left side what we're going to have is log base 6 of this x minus 5 times this x, and that's going to be equal to 2. And then we have log base 6 of distributing x squared minus 5x is equal to 6. And if we put 6 to the power of both sides, so I'm putting this 6, so on the left side we have 6 to the power of log base 6 of x squared minus 5x equals 6 to the power of, I said 6 to the power of 6. I meant to put 6 to the power of 2. There we go, that looks better. So log and log base 6 cancel each other out. So what we have left is x squared minus 5x equals 36. And I'm going to bring this up here to work below. We have x squared minus 5x equals 36. If we subtract 36 from both sides of the equation, we have x squared minus 5x minus 36 is equal to 0. And so what two numbers do we have that when added together equal negative 5, but when multiplied together equal negative 36? I'm thinking 4 and 9 have to be involved. So we have 4 and 9. Now which one's going to be positive or negative? We got negative 5x, so we got to have x minus 9 and x plus 4. So using the zero factor property, we have x plus 4 is equal to 0, and x minus 9 is equal to 0. So solving, x is equal to negative 4, and adding 9 to the other side here, we have x is equal to 9. And now we can plug back in. Now if we plug in negative 4, we're going to get log base 6 of negative 4 minus 5. Well, negative 4 minus 5 is negative 9. We can't have a log of a negative number. So we say x equals negative 4 is extraneous. So it's a solution we created in the process of solving. So x equals negative 4 is not a real solution. Now if we plug in 9, if we have log base 6 of 9 minus 4 equals 2 minus log base 6 of 9. Well, what is that going to be? We're going to have on the left side log base 6 of 5 equals 2 minus log base 6 of 9. And so if we add log base 6 of 9 to both sides, what we're going to have is on the left side just taking the, since we're adding here, we can take log base 6 of, we have 5 times 9, it should be 9 minus, should be log of 4, 9, yeah, 9 minus 5, that's going to be 4, So we have 4. Yeah. What that's going to be, it's going to be log base 6 of 36 equals 2. So on the left side, 6 to the power of what equals 36? We have 2 is equal to 2. So we have x equals 9 is a real solution. So that is our answer here. X equals -4 is extraneous. So that's it. We're going to do some exercises later on in this chapter. I hope this has been helpful. Thanks for viewing.